Hello and welcome to Unit 5, Part 5. My name is Mr. Bell. Today we're going to use a box and whisker plot to analyze and compare data. On this slide you will see a box and whisker plot. This is the part they call the box, and then the two things poking out to the side are what they call whiskers. Basically what this is a way to represent data. So what we're going to do is we're going to look at a set of data in a little bit, and we're going to organize it into a box and whisker plot. And what it does is it breaks your data down into quartiles. Quartiles mean quarters of the data, or 25% chunks. This would be quartile 1, the lowest 25%. This is quartile 2, quartile 3, and quartile 4. The four different groupings of 25% of the data. Some of the components of the box and whisker plot are very easy to do. The minimum value is a very easy point to plot on the box and whisker plot, and the maximum value is a very easy point to plot. That's the minimum and maximum of your data set when rearranged from small to big. And I'm going to teach you on the next slide how to find the different quartiles, and we'll also answer some questions about their meaning. This says box and whisker plots can be used to represent data. It's useful for dividing data into four quartiles. We said that a second ago, which just represents 25% chunks of data, and view distributions quickly. Make a mental note that sometimes they'll group quartiles together. For instance, from Q1 to Q3, that box actually represents 50% of the data. This quartile was 25%, this one was 25%, together they make 50. All right, now let's actually complete a box and whisker plot on the next slide. All right, on this slide we actually have a set of data, and we're going to fill in or create this box and whisker plot and see if we can answer a question about it. Step one when you're given the data is to rearrange them in order from smallest to largest. And remember, I like to cross them out once I find them. So we have a 70, an 80, an 84, an 88. Looks like 90 would come next, 92, 94, 95, making 98 the largest. And now that I've rearranged it, I'm going to go ahead and put in my minimum value, which was a 70, and my maximum value, which is a 98. Two parts of my box and whisker plot are already finished. And the magic operation that we'll need to do here to find the quartiles is median. And recall that to find the median, you find the number in the middle of the data. So I'm going to kind of work my way in to see which one lands in the middle. Looks like the 90 becomes the median of my data set, which will also be the Q2 of my data is at 90. So the center, the median of my box and whisker plot, the quartile 2 marker is 90. Now to find quartile 1 and quartile 3. To do that, you just find the median of the lower and upper halves, so to speak. So I'm going to find the median of these first numbers to the left of my original median. And in this case, there are two numbers in the middle. So I have to find the average of those two to find the median. 80 plus 84 divided by 2 would give me a median value of 82. That would be my quartile 1. And then for quartile 3, I've got to find the median of the upper half of the data, in which case there are two numbers again that land in the middle. So to find the median of those two numbers, you add them together, divide by 2, and I got 94.5 for my quartile 3. Now I have completed my box and whisker plot, remembering that I have the minimum, the maximum value. I know that 25% of the data is here, 25% of it's here, 25% of it's here, and 25% of it's here, representing the quartiles. Question says, what percent of the class scored above 82%? So I'm looking for what percentage of the class scored in this range that I've highlighted in red. And if you think about quartiles, I bet you'll recognize that 25% are here, 25% are here, 25% are here. That means 75% of the class scored above an 82%. All right, thanks for watching and hope this helps with box and whisker plots.